Alrighty, in this video we are going to be talking about cross sections, and so far in 6A we've only talked about circles as our cross section with disc and washers. But in this lesson we're going to talk about what if squares or rectangles or semicircles or isosceles right triangles with a base as a leg being your cross sections. So we're going to derive some of these formulas, and then we are going to look at number one in this video. And then on the next video, we'll work on some examples. The area of a square is easy peasy lemon squeezy because that's just b squared. You have a base and you have a base. Nothing to it. Same thing with a rectangle. Let's say that you have a base and let's say you some arbitrary value a. So your area is going to be a times b depending on what a is. Sometimes they might say that the height is half of the base. So if that's the case, then your area is 1/2 b squared. Or sometimes they might say that the height is just 1/2. So your area is just 1/2 base. Just depends on what your arbitrary value is. So that's why I'm going to leave it as a. A semicircle, this one gets a little bit tricky because remember that the area of a semicircle is just 1/2 pi r squared. However, this whole thing's your base, and you want everything to be in terms of b. So we know that your radius right here is going to be 1/2 b and 1/2 b. So if your radius is 1/2 b, then you're going to have 1/2 pi, 1/2 b squared. And that, if you were to clean it up a little bit, you're going to get 1/2 pi times 1/4 b squared, or 1/8 pi b squared. 1/8 pi b squared. Now, it's also important to mention that if you see a semicircle, it will not always, 99% of the time, it might not be 1/8 pi b squared. It just depends on what your base length is. In this case, I took a base to be b. If your base was 2b, then you know that your radius is just going to be b. So remember that everything depends on what your base is going to be. In this next example, we have a isosceles right triangle, and we know that that is just a base. And if we have a base right here, your other base is also going to be b since it's an isosceles right triangle. And we know that the area of a triangle is 1/2 base times height, 1/2 base. Your height is base, so your area is 1/2 b squared. Now, once again, this is where we get a little bit tricky because now we have an isosceles right triangle with the hypotenuse as the leg. So instead of your base, we have the hypotenuse as the leg. All right, what I'm going to do is draw a perpendicular bisector across the vertex. That's going to split up my triangle into two parts. This perpendicular bisector is going to be, remember that your two sides, are going to be congruent to each other. This doesn't look congruent because I'm a horrible drawer, but we're going to pretend that they are. And if they are congruent, then this is going to be 1/2 b, and this is also going to be 1/2 b. Now, this is still a 45-degree triangle angle, and this is also a 45-degree angle. Because we drew a perpendicular bisector, this tells me this is 90 degrees and this is 90 degrees, which tells me this is going to be 45 and this is going to be 45. So this perpendicular bisector splits up this angle right here. Which then leads us into another 45, 45, 90 triangle with a base as 1/2 b. Well, if I'm trying to find out what my height is, remember from this example that my height is going to be the same thing as my base. So if 1/2 b is my base, then my height is also 1/2 b, meaning that your height is 1/2 b. And remember that the area of a triangle is 1/2 base times height. Well, we know that my base is still going to be this big thing right here, aka my hypotenuse, which is still b. But then your height, which we found earlier, is 1/2 b, which means that your area is going to be 1/4 b squared for an isosceles right triangle. Of course, it depends on what your b value is. So in a couple examples in the next video, we'll see that it's not going to be like this. Okay, my equilateral triangle, that's going to give us a 60, 60, 60 degree angle. But then what I'm going to do is draw a perpendicular bisector again. So not perfect, but you get the idea. This is going to be 1/2 B. This is going to be 1/2 B. And this is 60, this is 90, this is 90, this is 60. This 60 degree angle right here turns into 30 and 30. So this gives us a 30, 60, 90 triangle. Now, remember with a 30, 60, 90 triangle, to find my height, which is going to be my 60 degree angle right here, opposite of my 60 degree angle, that is going to be √3 times whatever my base is. In this case, since my base is 1/2 base, this tells me my height is going to be √3 times that. So √3/2 times b. So that right there gives us my height. My equilateral triangle, once again, is 1/2 base times height. My base is still b right here. And then my height, which we found earlier, is √3/2b. And then if I were to simplify that and make it pretty, this means that my area is going to be √3/4b squared. All right, so what we're going to do with these formulas right here is to write, but do not evaluate, an integral expression with this region right here. So what we're going to do is make squares for part A in terms of my cross-section. We're going to take infinitely many squares, find the area of them, and then add up the area to get, of course, the volume of my region. Well, we know that the area of a square is base square, and we just got to figure out what my base is. Remember, my base is going to be whatever my vertical distance is. In this case, it's top minus bottom. So here I have f of x minus g of x. So my base for all of them is going to be f of x minus g of x. In this case, if I'm going to make an integral expression, I'm going to go from 0 to 1, since my bands are from 0 to 1. And then I have b squared. In this case, I have top minus bottom, f of x minus g of x squared dx. Okay, part B, we have quarter circles. Remember that a quarter circle has an area of 1/4 pi r squared. It's also important to note that your base is already your radius. So if I were to draw this out right here, oops. This right here is already your radius. It's this right here. So because I'm doing top minus bottom, and this is already my radius because it's a quarter circle, this means that my expression is going to be from 0 to 1, then f of x minus g of x squared dx. And of course, don't forget about your pi over 4 with your quarter circle. Your semicircles are going to be a little bit different. Like we said earlier here, your base is going to look something like this. And remember that area that we found, that we derived earlier, is 1/8 pi b squared, where b is your base. In this case, my base is my top minus bottom, or f of x minus g of x. So my semicircle, my semicircle is going to look like pi over 8, the integral from 0 to 1, f of x minus g of x squared dx. All right, let's say that we have a rectangle with height is equal to 4. So we have your base, and then we have a height being 4. Well, the area is just going to be 4b, so that's going to be 4 times the integral from 0 to 1 of f of x minus g of x dx. And then an isosceles right triangle with one leg as the base, we saw earlier that that's just going to be 1/2 b squared. Something like that. So we know that we are going to have 1/2 the integral from 0 to 1, and then f of x minus g of x squared dx. All right, so this video was just an introduction on cross sections and how to derive these formulas. In the next video, we will start evaluating with them.